speaker is Dr. Wendy NG from OneWeb. She's Principal Cloud Security Architect and Senior Security Advisor. Prior to joining OneWeb, Wendy was experienced DevSecOps Security Managing Advisor. She's defined and drove the strategy for the organization Global DevSecOps Transformation Initiative. Having written over 80 blogs, including an article for the Cloud Security Alliance, CSA, she also had the privilege of sharing experiences and observations from the industry at conferences, including keynotes at Black Hat and the Financial Times live webinar series. You'll find a lot of resources on YouTube. I invite you to check out. Wendy owned technical consulting skills from experiences in a number of industries. I've seen that too, including aerospace, healthcare, financial services, telecommunication, transport, logistics, and critical national infrastructure, a wide subject. She started her commercial career as a technical consultant at Cisco before working at PwC and Deloitte as a security architect. Oh merde. Ok. Je peux pas poser. Ok. Sorry for that. Last, Wendy is trained medical and data scientist with practical, we've seen in the keynote, data is everywhere, data is key, with practical experience in statistics, machine learning and AI algorithm. Wendy received a doctorate from the University of Oxford in 2007 and has contributed to scientific community through peer-reviewed publication. If you set up, maybe we'll wait just a few minutes.
That's okay. That's
Yeah,
okay.
we have
Sorry
few.
about the long intro.
No, but that's important to say it. I think a pretty impressive resume. Thank you for being there. Again, use the application Connects Me. Code is still CYSAT 2023. Locate yourself in the French Tech Room or area. I don't remember how it's spelled. And you can ask questions online. We'll start at 12 for time for people to come from the other conference. Thank you. It's okay. You don't want to. Yes, yes, you can. Thank you.
Hello. Okay. I've been involved in working with OneWeb for our next generation Gen 2 of LEO satellites, and specifically on the security architecture front. So I just want to sort of, before we jump in, I just want to say why we're here, why are we talking about, you know, LEOs, why is this an interesting cause. This slide, it's probably slightly out of date, I'm sorry, but it's a nice graphic. About half the global population don't actually have access to internet connectivity. Certainly not reliable internet connectivity. That has significant economic, educational, and operational, social disadvantages. Most of us in metropolitan cities probably, you know, rely on internet connectivity for many aspects of our day-to-day life, with regards to, you know, whether you're doing online shopping or you're communicating with friends and family. So it's, for those who don't have access to this, it's obviously slightly more problematic. And that's why we're sort of here talking about LEOs and cyber within LEOs. So the goal of OneWeb is that we connect everybody everywhere. We want to provide fast, reliable, and affordable, actually, internet connectivity. And we try, in terms of the sort of approach that we're taking, we believe it's more scalable to work with collaborators, work with local stakeholders, work with the telcos who's actually more familiar with their customer base and what they need. We want to, by partnering with sort of the existing sort of service providers, we are trying to combine the service of existing infrastructure with the ones additional offerings that and fill the gaps that's sort of currently for folks who don't actually have internet connectivity. Essentially, we're trying to be a bridge for connectivity dark black holes, so that we can actually offer the social, society, and efficiency advantages that come with having fast, reliable internet access. So we just had a conversation with Geo. So Leo, before I proceed, why are we talking about? I mean, we've been using satellites for actually decades for telecommunication. We've been using it, for example, I mean, I think most of us are familiar with satellite television, and that's been provisioned by GEO satellites in the past. We also have access to GPS system, satellite positioning systems, which is service offered by MEOs. The thing with the sort of thing with the jump, as it were, with GEO and what it brings in terms of connectivity, especially low latency or real-time connectivity, is the speed at which signals, the latency between signal on the Earth surface or user system to the actual satellites themselves, because they are positioned so much closer to the Earth surface. So the latency is sort of about 50 milliseconds. It's probably about 70 for us at the handoff at the customer side. Having that reduction in sort of latency as a result of using LEO means that it opens up a lot more assets and resources and services that wasn't previously possible with GEO or satellites which are positioned high up in the Earth's orbit. So that's they involve higher, longer latency. So, I could do like a parody of this, but I thought it's probably better for me to just play the video and just, this is just a demo of what our system does.
Unlike geostationary satellites that operate at an altitude of 36,000 kilometers, the OneWeb system operates at 1,200 kilometers, resulting in significantly lower latency and better system performance. Our system will provide full global coverage, which is shown here. The gateways are shown here in red. The teardrops moving around illustrate the OneWeb satellites in orbit, which will communicate with the gateway infrastructure for connection to the internet. End users will connect to the satellites via OneWeb user terminals. As satellites pass over users, the terminals, represented here by a white dot, will hand off connections between beams and then to the next approaching satellite. The resulting connection and connectivity will provide high-speed access as shown in the download simulation here.
You guys heard that all right. So in that, okay, sorry, it lost my slide for a bit. So in that video, there are three low Earth orbit satellites. There are actually three components. There's the satellite, there's the satellites, there are the ground stations, and there are the user terminals. So I think most of us, when we think low Earth orbit satellite, we just think just the satellite themselves. But actually, there are other parts of the system which are required for internet connectivity. I think I'm running a bit behind, so I'm just going to go slightly faster. So this is I'm involved with helping with the security architecture of our new system. We are using a lot of industry sort of standards, and this is I can't unfortunately show you what our current system look like or what we propose it to be, but this is a high level adaptation of the three main elements for any satellite communication system, whether it's LEO, GEO, or MEO. So you always have the user terminals. You have obviously the satellite communication system, and that's split into two interfaces: one for payload and one for the communication, the controls aspect of it of the satellite. And then you have the ground stations, which is there to act as effectively a concentrator. To connect the network to local or wide area networks on the ground, terrestrial networks on the ground. So those are the three systems. Now, all three systems rely on applications. So everything runs on applications. And I think, additionally, most commercial applications consist of 75 to 80% open source libraries. So this is where people, this is sort of the community have a set of libraries which is sort of shared developers. Very few of the actual application is bespoke code. So in terms of controlling, if I go back, all three segments, the most important thing in terms of your development, application development, is that you ensure that you integrate security into the application development process, and you integrate security assurance, and that includes scans for the entire life cycle. It's not just application development, for the entire life cycle of the of your services. Finally, there's also supply chain. So for GEO or LEO, the satellite communication, you're going to have a supplier, obviously. Do you trust the supplier? What are their processes? What are their procedures? It is effectively a manufacturing game with satellite communication with LEOs, given the number that we have to have. So our satellite constellation is about 650. So it is effectively a mass manufacturing of that number of satellites that's required to provide global connectivity. When you actually, when it's been manufactured, how is it distributed? Where are your satellites? Who has access to them? What are the processes and procedures in place? When you're engaging with partners, and we are engaging with partners as we start to offer our services, how are you engaging with them? What's the partner's security posture? What processes, procedures they're doing? If they're helping you with software development, if they're a vendor that provides software development, are they doing the due diligence in terms of security assurance in as part of that process? And are they doing regular scans after deployment onto after operations? I mean, two of the main in the last few years, two of the most impactful vulnerabilities, Heartbleed and Log4 Shell, they were all from open source libraries. That's basically only discovered after people integrated them into thousands or hundreds of thousands applications. So it's that, you want that assurance process, and you want that your partner to be on board with you. Your operations, operating your interactions with your partners and also your own operations. Are you doing what's necessary? Are you using multi-factor authentication to access materials? Are you effectively cutting people's access? Because most, we talk about security, but most security issues, believe it or not, is actually by the actual vector is human. It's phishing, and it's people doing things that they shouldn't have done. So do you have the process in place in addition to all your security controls, good encryption, relevant encryption mechanisms, and making sure that your application is up to date and doesn't have any known vulnerabilities that attackers can take over. So if this finally, I think the reason we're sat here talking about this is because if low Earth orbit satellite can provide such a game changer in terms of how we leverage systems we can use as part of our kind of societal development, you can effectively use it to sort of control autonomous vehicles. There's a lot of, we're talking about with the war that's happening, we've got a lot of sort of resource issues. So a lot of this resource, energy and resource monitoring and excavation, they're all from really remote sites that's not connected. Obviously for apps and as well as sort of, industrial automation and, sensor monitoring. That's actually quite an important field for crops or animal husbandry. And obviously telehealth for those who doesn't have access to nearby doctors. So I hope you guys still awake. Let me know if you have any questions.
First, thank you. Thank you for this presentation. Do we have any question in the room?
And just, I'm very pro kind of collaborating with the industry. So since we're working on it, if there's any questions from the security architecture aspect of it, please come and find me afterward if you don't want to ask a question right now. I see someone nodding there.
I may have one actually. When you are defending a system, you have to think about everything, the whole chain. You talked about the supply chain, but you have to consider the ground, link, space, and so on. When, unlike the attacker, which an attacker has only one vulnerability to find. We saw it with the CYSAT case. What have you found the most challenging to achieve?
As in sort of protecting our state.
Yeah, what kind of component or phase was the most challenging?
It's the human, unfortunately. It really is. I think quite a few, if you, apart from some of the, if you look at outside of SATCOM, right, if you look at in other industries, and I worked in other industries previously in security, it's the probably main vector is probably the human, actually. The second one is application, definitely application. Just you know, people, they don't, you know, they sometimes they don't even necessarily have a security assurance. They don't do scans in their development, and once it's out, they sort of, it's just like, here you go, here's the product, see you later. So you need that continuous checking until that you retire that service or product. So I think those are the, yeah. Okay.
We've seen on that side, on software, we've seen many, I would say, initiative, including from ECSS, with a standard in the work on maybe I would call it secure software development lifecycle. Have you deployed any such programs, or what's your return on experience on that?
So we are. I need to be careful how I do it. You should do secure software development. You should do security assurance. You should do open source scanning. You should do static scanning. You should do dynamics test for your applications, and you should do continuous assessment after the process. We do actually. We probably don't have that much of a sort of IP application at the moment, but we do check our vendors that they are following due process best practice. I mean, I think our customer and the regulators expect it. You don't want to be pulled into. Yeah.
Okay. Do we have any questions in the room? I could go on, but. Yeah.
Yes, good morning. Do you identify specific threats due to constellations?
What do you mean, identify specific threats?
I mean, jammers or whatever.
So we do threat profiling in terms of what they're at risk. I think let's go back to so of these three segments, right, I think, you can't see it, but of the three segments, actually I think the satellite is probably the least vulnerable part, just because it has pretty good physical security. And for LEOs, I mean, they make multiple, because they're not in the same position, so they kind of whisk around the sort of surface. So that you only if you're an attacker, you only have a specific amount of time to actually try and brute force attack a particular satellite. So it's for us, it's not the main. I've said this before. The main thing is probably the user terminals, because those are effectively IoTs. They're very sort of lightweight devices. They're not. Sometimes, we have potentially relatively little control once they're at the customer site. So that is, out of the three segments, that's the most vulnerable segment.
Hi. You have experience with OneWeb, yeah. I heard. Is it possible?
Only Gen 2.
Yeah. Is it possible to affect the functionings of the constellation? I'm talking mainly about the payload through a user terminal. Is there anything that a user terminal can affect on the resources on board or the control and management of the constellation that could affect the availability or integrity, or
Yeah. So I'm not being massively fair here. So I know it's sort of connecting user terminal to the satellite connectivity, but we can actually, there are, if we don't have, if for whatever reason there's a, we've sort of identified vulnerability or something that's not quite right, we can actually control it at the local network level. So there's multiple sort of layers of control that we can add. So it's not a direct connectivity.
And you are talking about direct controls on the ground control segment, controlling the payload, avoiding any compromisation by the user terminal, or are you talking about the firmware in the user terminal being managed by the control?
So, sorry, let me clarify. I thought you were asking whether the firmware could pose an attack vector for the whole system.
Yes.
Okay. So, firmware, we're connecting it to, there's going to be some local connectivity. So if there's vulnerability, if there's an attack vectors there, or if there are risk points, you can actually apply sort of secondary defense mechanism around it. We can provide network control, for example. In terms of the ground control segment, that's got pretty good physical security, and that's monitored to the hilt. So if there's anything that's sort of, we're quite good in, at least on the operational side of it. We're sort of very cloud first. We use the as all of the controls that's sort of available, and the advantage of that is just gives us a bit more visibility than if you were. Sort of a legacy system, for example.
Thank you.
Thank you.
I have another one there.
Good morning, Antonios
Hi.
Atlasis from the European Space Agency.
Good.
I have a question related with the number of the satellites in such a large constellation. Do you start encountering challenges that we faced or used to face only in the terrestrial network, like, for instance, routing? How do you manage routing in the constellation, and if you see any risks related with some kind of DDoS attacks because of some kind of routing hijacking, for instance?
So I actually started my career at Cisco, so I came from a networking background. To me, the satellites, they're basically just a router. They just route it in the air. I think historically, there's probably less of a need. I understand your comment. So there's less of a need to possibly protect it, because it has, for geos, it's mostly for the communication is one directional. So with LEOs, and I think that's why part of the reason why I think it would be good to sort of, I'm just putting it out there, to sort of start discussing about having a discussion about how we can as a community make things better, because there's so much more connectivity involved. We are effectively looking at IoT. The threat profile is so much bigger. I'm not sure if I answered your question. Your question was whether there's routing problems.
Exactly. For instance, do you use dynamic routing? Are there in the satellite links, and you have to take into account some dynamic routes?
So currently, the Gen 1 doesn't have any inter-satellite links, but we do. There is cross implemented. So yeah, dynamic routing. Yeah.
I'm bouncing back on the question of the gentleman. I'm assuming that most of the user applications are more and more cloud-based. Does that make a difference in terms of security, or not at all?
So I'm for cloud. So just full disclosure there. I think you can get a lot more visibility from adopting public cloud. You've got also have a much bigger user base that you can share experiences with, and if you're a large organization, because they have such a large user base, it's much easier for them to make the business case for sort of security type controls or new security controls. So I'm actually for cloud. I think this, in terms of visibility, is good. In terms of the user community, is good. I mean, for the DevSecOps software development stuff, I think if you're not started, unless there's some kind of regulatory reason, I think you should just go straight to a public cloud provider. It's just there's so much more, assets out there, templates.
We have one question there.
But it doesn't mean that you can't get hacked if you use the cloud. Using. So.
Yeah, I got a quick.
I think on the whole is safer, and for the security folks, we get more visibility.
Right here in the back. So you mentioned the satellite being maybe least vulnerable from your perspective, and the user terminals being more vulnerable. So citing physical access and line of sight being two security controls. What other security controls that you have, or are you thinking about deploying, kind of ignoring that fact of the physical access? Because with supply chain, with various attack vectors, like those physical security and the line of sight doesn't really apply. So is there detect and recover capabilities built into the satellite, and what type of controls and countermeasures are on board?
So we do rely just the whole infrastructure, but so I wasn't involved with the Gen 1 satellite, but for the Gen 2, we are about, I think this is in the public anyway, we're about to go do RFP. We are giving our architecture and engineering teams sort of ideal states, taking account all of the, based on NIST actually, 853, taking account of all of the five areas. So yeah.
Yeah. So we've done a lot of work. I work at the Aerospace Corporation, a nonprofit. We've done a lot of work doing exactly what you're talking about, taking the NIST guidance and translating it specifically to the space vehicle to say how you actually implement certain countermeasures on a spacecraft. So be happy to share that.
Oh yeah, it'd be good to catch up afterwards.
Yeah. And I got to talk tomorrow talking about this a little bit as well.
Fantastic. Thank you.
We still have a few minutes for questions.
I'm sorry, everybody. I was watching that clock, and I thought that clock countdown was how much time I had, but.
So you mentioned Gen 2. I assume in your design you're considering 5G NTN. I'm here.
Okay,
you're considering 5G NTN as one possibility, and in 5G there is native security for authentication, for encryption. Is this something you consider enough reliable so you can build your satellite design on, or your system design on 5G native security features, or would you add extra feature or move away from 5G native security?
So I think it does depend on a user case. So OneWeb as an organization, we're trying to. It's always a balance between what is sort of the most secure and sort of what is manageable overhead. So we. I can't go into specific about sort of Gen 2, but if there's been a sort of established standard and it's out there and people have tested it and there's no reason for us to believe that it's insecure, I think that's what we will leverage, unless there are specific, apart from some specific side user cases.
Another question, maybe? No. I think we've already had a lot. Thanks a lot for your
Thank you.
answers. Thank you, Wendy.